Can we do 24
Yes.
from the homework that was due to
Yes,
today?
I don't know what the 24 page section, what do you mean 24 by?
I can just tell you what it is.
Yes, please.
It was f to the t equals
F of t equals,
t to the third exponent minus 5t over, and then e to the fourth power, and then t next to it to the third power.
okay, this one?
Yes.
So t to the third minus 5t over e to 4t to the third. I'm just checking my memory. We did something similar, we did not?
Yes, we did.
Okay, that's fine. No worries, no worries. I'm just, again, when you get to my age, you want to check your memory. Okay, perfect. So I'm just looking at it and see if it's beneficial to change it into a product. Maybe. So t to the third minus 5t e to negative 4t to the third. So what are we asked to do is find the derivative?
Yes.
Okay, perfect. So f prime of t. The first function prime, 3t squared minus 5 times the second one, plus t to the third minus 5t times the second function prime, which is e to negative 4t to the third, times the inner function prime. I will factor out e to negative 4t cubed. From here I have a 3t squared minus 5. And now I have to distribute negative 12t squared to these two terms. So negative 12t to the fifth and plus 60t to the third. Power 5, power 3, power 2, and no power. This is it. So e to 4t to the third, 60t to the third, minus 12t to the fifth, plus 3t squared, minus 5. This is what I would do because the denominator is just one term. If it had two terms, I would have not. Good. Perfect question. Thank you. Any questions on this question?
I do.
Yes, please.
If the top part is not in that order, is it wrong for the answer?
Here?
Yes.
No. No, it's not. But we always present polynomials in descending order.
Perfect. Thank you.
But no, it's not wrong. You will not get points off from that. But always keep in mind this is the rule. All polynomials in descending order. Good. Next question. Anything else you'd like to work on? Anything else you need help with? Please, anything else? Okay, then, in that case, we will start chapter 3. Chapter 3 is a long chapter. It starts with 3.1 and ends with 3.9. So 3.1 through 3.9, not 3.7, but everything else. Okay, so I'm going to already go to the next page. One application, so the title is Applications of Differentiation. We have many applications to look at here. The first one is graphing functions. graphing functions. It's a major application, very important in this class. Now, you can say I have a graphing calculator, I'll punch it in. It's not going to work. No credit will be given for that. So there is a huge theory as an application of differentiation in graphing functions. The first thing we're going to talk about is something called critical number or numbers. What is a critical number? It can be called a critical value and so on and so forth. It doesn't matter. But critical numbers, first of all, they come from two sources. So a critical number is a number of a function that potentially comes from two sources. Source number one, when f prime of x is 0. And source number two, when f prime of x is undefined at the value where f of x exists, is defined. So what's such a big deal about critical numbers? Well, it's a big deal because if a function does not have critical numbers or number, it is guaranteed not to have max min. Guaranteed not to have max min. Now, if it has critical numbers, is it guaranteed that it has max min? No. But if it does not have, it's guaranteed not to have max min. Critical numbers may change, or if you want, become max min. They may become max min. No guarantee. Again, if a function does not have critical numbers, it will never have max min. Critical numbers or critical number may change. They may become max min. Emphasis is on may. So let's look at a function. And we can choose a function. I'm going to open the book. And I let you choose a function so we can determine its critical numbers if they exist. No guarantee. Okay, I'm almost there. I was logged out at some point and I closed up everything, so then I forgot to open the book. Okay, and we're on page 276. If you're there before I do, that's absolutely fine. I'm sharing my screen. $276. Okay, so we don't talk about anything yet, just critical values or critical numbers. So either 276 or 277. So let's choose a function from 19 to 32 and look for critical numbers if the function has any. If you do not choose, I will.
Do 21.
Perfect. 21. 21 on page 277. And that is x cubed minus 6x squared minus 15x plus 1. So we are given a function. We're asked, does this function have a critical number or critical numbers? Remember, we have to check both sources. We have to check if this equation has solutions, they will become critical numbers. And if f prime is undefined where the function is defined. It doesn't mean that all functions or functions have to have critical numbers coming from both sources. No, it does not mean that. It means that we have to check both, no matter what. Okay, so in either case, I have to determine f prime of x. Can anyone quickly give us f prime of x, please? F prime of x.
3x squared minus 12x minus 15.
Excellent. Very good. Of course, I am going to factor out a 3 here to see if I can quickly factor x squared minus 4x minus 5. And I realize that I can quickly factor into x minus 5 and x plus 1. And this was very helpful. So now I'm checking both sources. Source number 1, f prime being 0. Can anyone give us the solutions when we solve the equation f prime of x equals 0? Please.
5, negative 1.
Yes. So x equals 5 and x equals negative 1. Critical number, critical number. Source number 2. Is f prime of x undefined? Is f prime of x undefined? Anyone, please?
Yes.
F prime is a polynomial function. So polynomial functions are never undefined. They are always defined on all real numbers. So these are the only critical numbers. So the function has two critical numbers, and they are negative 1 and 5. We don't know at this point if they change into max or min. We do not. So right now, I just want to practice one more, and then we'll go back and discuss if these become max min or not. So I like to choose one more problem. I will choose number 29. In 29, we have f of x equals x e to 4x. Good. Again, the same question. Does this function have critical numbers? I don't know. I have to find f prime of x. Can anyone give us f prime of x for this function, please? Please, for 1 minute, work on f prime of x. 1 minute. and let me know what you get. Just give me the raw form of the derivative. Don't do anything. Just give me the raw form.
Is it e to the fourth x times 1 plus 4x?
So let's see. First function prime, e to 4x plus x e to 4x times 4. Yep. Yes, we will factor out e to 4x. I completely agree. And we get 1 plus 4x. I agree, all the steps. Excellent. Thank you so much. Perfect. So now we have to check f prime of x equals 0 to see if this equation has any solutions. And number 2, I have to check whether f prime of x is ever undefined. Let's start with this one. Do you think that f prime of x, this function, is ever undefined where the function is defined? What did we learn about e to a function or e to 4x or just the exponential function? What did we say about e to a function or e to 4x in this case? What is the domain of e to 4x? Or any exponential function, what is its domain?
All real numbers.
Excellent. And this, what is the domain of a linear function? It's a polynomial function. What is the domain?
All real numbers.
Of course. So there is no such thing. No. Good. So when we set this equal to 0, remember the graph of e to 4x. The graph of e to 4x never touches the x-axis. So this can never be 0. So the only quantity that could be 0 is 1 plus 4x, which means x equals negative 1/4. And this is the only critical number. There is no other. It may or may not change into a max-min. But if a function does not have critical numbers, it's guaranteed not to have max-min, period. Okay, now I would like to go back to the first example and also to the second example and discuss and see if those critical numbers for the first example, negative 1 and 5 that you picked, and the other example for x equals negative 1/4, negative 1/4, if they change into or if they become max-min. Okay. So let's take a look at the following graph. I need to explain something before we proceed. Notice what happens here. At this point, if I want to draw the tangent line, can you tell me if the tangent line has a positive slope or a negative slope? This one.
Positive?
Yes. What about here?
Positive?
Of course. What about here? What is the slope here?
0?
Yes. Good. What about here?
Negative?
The same thing here. And what about here?
0?
Yes. So we call this a local or relative, same thing, we use them interchangeably, max. So this point is a local or relative max. Obviously, this point is a local or relative min. But see what happens left and right. The slope of the tangent line, which is the sine of the derivative, is positive. Then after the maximum, after the local or relative maximum, the sine of the derivative is negative. So this is typical situation for a maximum. Positive derivative, zero derivative, negative derivative. Typical situation for a maximum. What about here? Negative, zero, positive. Typical for a minimum. So, and these have to be the critical numbers. So, two possibilities. Positive, zero, or undefined. Careful. Why? Zero derivative or undefined derivative. Both are possible sources of critical numbers. So, positive derivative, zero or undefined derivative, and then negative, typical for a max. Negative, zero or undefined, not both, one or the other. Positive, this is typical for a minimum. This is the way we are going to check whether -1 and 5 and -1/4 become max min for the respective functions. Okay. We're going to present all the work in a table. This is mandatory. All the work has to be summarized in the table, please. Don't just write something or copy from the graphing calculator. It will bring no points. Okay, so this is for our first function. The first function was a polynomial function that we picked, x to the third, . So it has domain all real numbers, and the critical numbers we obtained were -1 and 5, -1 and 5 in the correct order from -infinity to infinity. We know that the first derivative is 0 at those points. The first derivative is 0 at -1 and 5. We are going to, I'm going to copy the function here so I don't have to go back to those pages again. So where's my function? My function is this, x to the third minus 6x squared minus 15x plus 1. We are going to plug in the function -1 and 5 to see the function value at the critical numbers. You know exactly what I'm going to do, so let me